In question 3, it is given that x equals to ln of 1 minus y minus ln y. In part 1, we have to show that y equals to e power minus x upon 1 plus e power minus x. Now, as in the question, we have to make y the subject. So as the original expression is x equals to ln of 1 minus y minus ln y. As there is a negative sign, so we can write this as ln 1 minus y upon y. Now, as this is an ln function, so we can now simplify it as, and just for revision, we know that if it is ln of x is equals to y, we can write it as x is equals to e to the power y. So in this case, we can write this as e to the power x is equals to 1 minus y upon y. Now we have to make y the subject. So first we'll cross multiply. This will become y into e power x is equals to 1 minus y. Taking y on the left hand side, we'll get y into e power x plus y equals to 1. Taking y common, we'll get e power x plus 1 is equals to 1. And finally, we'll get y is equals to 1 upon e power x plus 1. However, as the expression said, e power minus x upon 1 plus e power minus x, we need e power minus x in the numerator. So what we can do is we can just multiply and divide by e power minus x in the numerator and the denominator. So the numerator will become e power minus x, and then e power x into e power minus x, that will become 1, and 1 into e power minus x, that will become plus e power minus x, which was the expression we needed, which was y is equals to e power minus x divided by 1 plus e power minus x. Now in part 2, we have to show that the integral of y dx with limits 1 and 0 is equals to ln of 2e upon e plus 1. So in place of y, we can use a substitution e power minus x upon 1 plus e power minus x with the limits 1 and 0. Now, to integrate this, we can see that we need the derivative of e power minus x in the numerator. So as the derivative of e power, so if we differentiate e power minus x, that becomes minus e power minus x. And as we need the derivative of the denominator, so which is 1 plus e power minus x, so that will be also equals to minus e power minus x. Now, in the first step, as we need a negative sign, so we'll put up a negative over here, and we'll also multiply this equation by minus 1. Now, integrating, we'll get this minus and ln of 1 plus e power minus x as the integral. Now, substituting the limits, which are x equals to 1 and x equals to 0. So substituting x equals to 1, we'll get minus ln of 1 plus e to the power minus 1. And we'll subtract it from the lower limit, which is 0. So this will become minus ln of 1 plus e to the power 0. Simplifying this, now first we can write this as 1 plus 1 upon e. As in the expression, we can see that we don't have a negative power with the exponential function. So now this will become plus ln of, and 1 plus 1 becomes 2. Now to make it easier, we can write this as ln of 2 minus ln of, and over here we can take the LCM. So this will become e plus 1 divided by e. Now when it is subtracting, we divide the function. So simplifying this, we'll get ln of 2, and this will divided by e plus 1 upon e. Simplifying this, we'll get 2 multiplied by e upon e plus 1, which is basically the final answer that we had to prove, which was ln of 2e upon e plus 1.